Solving exponential equations. This is the first video on solving exponential equations. Exponential equations have the variable in the exponent. And if you remember that exponents and logarithms are inverse functions of each other, well then it's very easy to understand that what you need to do to solve exponential equations is use logarithms. So let's take a look at this first one. We have e to the x power equals 17. What we want to do here is get this x down where we can work with it. Well, we know that the inverse operation of an exponential e to a power would be a natural log. So we're going to take the natural log on both sides of this equation. So we're going to take the natural log of e to the x, and we're going to take the natural log of 17. Now, using what we know about logarithms, the natural log of e to the x power is just x. So x would be the natural log of 17. This would be considered the exact answer. If I wanted an approximation for this, I could certainly find one. Natural log of 17 is approximately 2.833. So now let's look at the next problem. This is 10 to the x power equals 17. Well, here I wouldn't want to use a natural log, but I would want to use a log base 10. So I'm going to take the log base 10 of both sides of this equation. Now the log base 10 of 10 to the x power is x. So here x is equal to the log of 17. Again, if I wanted an approximation for that, I could stick it in my calculator to see that that is approximately 1.230, rounding to 3 decimal places. Now this problem is almost the same, except it's 2 to the x power. So here, I don't want to use log base 10 or natural log. I'm going to use log base 2 on each side. So I'm going to take the log base 2 of each side of my equation. Well, the log base 2 of 2 to the x power is x. So x would equal the log base 2 of 17. Now, if I want to put that in my calculator, remember I have to use the change of base formula. The log of 17 divided by the log of 2. And remember to close your parentheses. So this is approximately 4.087. Now these equations just have a little bit more to work with. Before I can do the log on both sides, I've got to get the exponent part by itself. So my first step here will be to subtract the 5 on both sides. So this will be 3 to the x power equals 7. Now, I take the log base 3 on both sides. So the log base 3 of 3 to the x power will give me x. So x is the log base 3 of 7. And of course, if I wanted the approximation for that, again, I would use my change of base formula. Do log of 7 divided by log of 3. I get that this is approximately 1.771. Here, again, same sort of steps. First thing I want to do is get this 10 to the power by itself because the exponent is here. I want to get that part by itself. So I'm going to add 12 to both sides of the equation, which would give me 4 times 10 to the 8x power equals 92. Now I want to divide by 4. That will give me the 10 to the 8x power by itself on the first side of the equation. And 92 divided by 4 is going to give me 23. Now I want to take the log on both sides, so I'm going to come over here and do this. So I'm going to do the log here. My base is 10, so I'm going to do common log on both sides. So this is going to give me 8x equals the log of 23. So to get x by itself, I just divide by 8. So x is the log of 23 divided by 8. To get that approximation, I would do log of 23, close parentheses, divided by 8. So this is approximately 0.170.